One of the main functions of a battery charger is to charge a battery or a cell. But there are different types of charges that can be given a battery. This part of the program will address a type of charge called a freshening charge. The key points that will be covered include the definition of a freshening charge, when it's applied, and the basic steps for applying it. A freshening charge is a charge that's given to new wet charged cells before they're put into service. Wet charged cells are new cells that are shipped from a manufacturer already filled with electrolyte and fully charged. Although wet charged cells are fully charged when they leave the factory, they will gradually self-discharge until they're connected to a source of voltage that's higher than the open circuit voltage of the cells. As the cells discharge, sulfation occurs. The resulting sulfate crystals can be difficult to remove with normal charging and can prevent the cells from taking a full charge. For this reason, a freshening charge is typically applied to wet charged cells before they're put into service. A freshening charge is a higher than normal charge voltage that's applied to wet charged cells before they're put into service to ensure that the crystals are driven off the plates and that the cells are fully recharged. A freshening charge is also sometimes referred to as a boost charge or an initial charge. Before a freshening charge is applied, the cells must be properly installed. In addition, the shipping vent plugs are typically replaced with flame arresters. Also, the electrolyte levels are checked to make sure that they're above the top of the plates. Water is only added if the plates aren't covered, and then only enough is added to cover the plates. Of course, when you're performing any kind of work on a battery, be sure to wear the appropriate protective gear and follow the required safety precautions. After the cells are prepared, a freshening charge can be applied to the battery. The charge is applied at a voltage and for a period of time that's specified either by the cell manufacturer or by company requirements. In general, the freshening charge is determined by the maximum voltage that the DC system loads can tolerate or the maximum charger voltage if load is not yet connected. For example, the maximum allowable voltage for this system is 58.8 volts. Voltage any higher than this may damage the control and protection circuits. This voltage is divided by the number of cells in the battery to determine the maximum voltage per cell, or VPC, that can be applied. This battery has 24 cells. The maximum system voltage of 58.8 volts divided by 24 cells gives a maximum of 2.45 volts per cell that can be applied. Generally, a freshening charge at 2.33 volts per cell is considered the minimum acceptable charge level. The number of hours that the freshening charge needs to be applied is typically specified in cell manufacturer instructions, or it may be specified by company procedures. To apply the freshening charge to the battery, the float equalize switch or timer on the battery charger is switched to the equalize position. Then the equalizing potentiometer is adjusted to provide the required output voltage to the battery. The output voltage is indicated by the charger's DC voltmeter. In this example, the output voltage is about 55 volts. It should be noted, however, that many utilities feel that a charger's analog voltmeter is not sensitive enough to be relied on for critical voltage adjustments. In this case, the DC voltage output can be verified by connecting a precision voltmeter or multimeter across the positive and negative terminals of the battery or across the charger output terminals. It's often recommended that the voltage be checked at the battery rather than at the output terminals of the charger because of the possibility of a slight line voltage drop between the charger and the battery. If necessary, the equalizing pot is adjusted to get the precise charger output required. Once the output voltage is set, the charger is allowed to apply the freshening charge to the battery for the required period of time. During the freshening charge, one of the cells is monitored regularly for temperature. This cell is referred to as the pilot cell. The temperature should not be allowed to rise above a certain point specified by the manufacturer. Generally, this is 110 to 120 degrees Fahrenheit or 43 to 49 degrees Celsius. The cells are also watched for excessive or violent gassing, which can distort the plates, create a high level of explosive gases or cause the electrolyte to overflow. The gassing shown here is normal. If the temperature approaches or exceeds the limit, or if overflowing or excessive gassing is observed, the freshening charge should be stopped immediately by turning the float equalized timer or switch back to the float position. The battery is left on float until the cells cool down to 100 degrees Fahrenheit or 38 degrees Celsius. Once the cells have cooled, the freshening charge can be resumed. After the battery has been properly given a freshening charge, it's typically placed on float charge. Freshening charge voltage and times can vary with the type of battery used and with the load limitations of the DC system. Be sure to determine the specific freshening charge voltage and time requirements for your system. This part of the program covered the definition of a freshening charge, when it's applied, and the basic steps for applying it. A charger may be used to apply two other common types of charges, a float charge and an equalizing charge. These two charges will be described in the next part of this program.